Hi guys, I'm Neil from CAD and Robotics.
And I'm Mueez. I hope y'all are ready because today we'll be CADing our very own electrical board. We'll be using a software called Onshape, so if you're not familiar with it or need a little refresher, I suggest you check out our previous videos on how to CAD using Onshape. And of course, the links for them will be in the description.
To break up what we're going to do today, we will be CADing an electrical board for a drivetrain with 4 Neos. In order to do that, I will be visiting the CAD of the drivetrain to see where we can place the electrical board and how big we can make it. Afterwards, Mueez is going to walk you guys through the general things to keep in mind when making and organizing your electrical board and how to CAD it.
Alright guys, so as you can see, this is the drivetrain we will be using for the rest of the vid. So, we go down to the bottom sketch. As you can see here, some caveats. The electrical board, the final product we'll be making, will be covering about this much of the drivetrain. You might be asking yourself why I can't cover the full length of the drivetrain, and that is because if we were to just make a plain rectangular piece of like sand, when we mount it onto the bottom of the drivetrain, the electrical board will be hitting not just these brackets at like the back of the drivetrain, but also these motors, which will cause some problems. You even have some of these brackets also at the front, so you're going to need to make cutouts to account for those parts. Another thing also is that we have these holes here. These holes will be used to help in mounting the electrical board at the rod and stuff like that. So we're also going to need to CAD for those minor sketches of parts. So let's start sketching. So as you can see here, we're at the top view, going to make a sketch, plane, R for a center point rectangle. Now, there were some dimensions to take note of that I needed, so we're going to be needing a width from that's going to be covering extending out to both of these rails, which is about 17 inches, and then for now I'm just going to, for the length, I'm just going to be making it to the full length of the drivetrain, which is about 35 inches, but that's obviously going to change. So dimension, which you can see here with the hotkey D on Onshape, 35 inches, and then a little bit out to make it 17 inches there. And after that, I'm going to be sketching out the brackets at the front of the drivetrain. So just making some random lines, and I'll be dimensioning later. Okay, cool. So here, 1.5, 2, I believe 1 inch. Yeah, and this should also be a constraint. Make this equal to this. There. There are other ways you could dimension this, but that's the way I did it for now. And after that, we need to obviously duplicate it on the other side. So I'm going to mirror these images. So, boop, boop, there, and there. And voila, it's copied onto there. So after that, I'm just going to extrude it for now, and then after, I'll just be mounting what I have right now onto the drivetrain. So, alright, there, a symmetric sketch. The thickness of Lexan is about 1/8 of an inch. So, enter, and now some final customization changes. Renaming this into electrical board. Assigning material. Typically for us, we assign polycarbonate to our Lexan. And then any appearance you want to, I'm going to just turn down the color to make it look somewhat like Lexan. And then, at least the final step, at least for now, we're going to fillet the edges. By doing that, it lets the router have an easier job when going around corners while routing. So there. There. Here. And then with that, I have this edge, and then this edge, and that should be the last fillet. So finish that, and oh, okay, cool. All right. So, going back to our drivetrain home view, we're going to insert the current drivetrain. Excuse me, current electrical board that we'll be using. So there it is. Then going to fasten mate the top of it. To the bottom of the drivetrain. So now let's check here. All right, looking pretty good so far. And then obviously, as you can see here, as to why we're gonna have to cut parts off, as you can see, the motors extruding, going through the Lexan, even the same thing with these back motors here. So we're gonna have to cut from the original design here. So go back here. I don't remember the exact measurement I had to delete from there, so we're just gonna guess and check. Now let's see, about 9.5 inches. Shave that off. All right. Let's see. Let's see how that looks. Oh, it actually looks pretty good. All right. So, okay. Yep. All right. Looks good. So now the last step will be to CAD the holes. Now, what I could do is I could manually go back into the sketch and sketch out all these circles and make a pattern from them and whatnot. You know, do the same thing for these sides here, but that takes too long and I'm pretty lazy. So the feature I'm going to use right now, which saves a lot of time, it's called editing in context. So if you do not know, editing in context allows you to view a sketch of a part while it's on its assembly. And the big reason why I'm going on to here, why I'm editing in this style, so I could properly use a little function or feature called the project feature, which can be accessed by pressing U on the computer. So the project function, what it does is that it allows you to project sketches of other parts that are not the one you're editing right now, like parts from other parts in the assembly. So as you can see here, when I clicked on this hole, it basically projected a circle onto the sketch. So we're going to be doing that, but for all the holes that we need when mounting this electrical board. So if I can get a good angle, all right, project, and then to highlight here. All right, cool. All right, now we're going to do the same thing. I could highlight the whole leg or rail, but the thing is, if I were to do that, it would accidentally highlight also this indent here, this cutout, which I do not want. So I'm going to do it separately by each section. So there. Hope it gets out. Alright, cool. That's there. Going here. Let's see. Should load. Going to go back to. Alright, cool. And then finally, these bad boys here. And then that should load. Alright, cool. Now, to make things even more easier, we're going to mirror the holes we just projected onto the other side. So, let's see. Alright. Ooh, I accidentally created a double. But that's alright. Okay, there it is. So, once you press enter, voila! There are holes. So, when you go back into the assembly, there you go. Alright, yeah, we have our electrical board base. Yeah, look at all the holes here. Looks pretty good. Not conflicting any parts here, and we cut enough to where it won't conflict with the motors at all. Alright, cool. Alright. Nice.
That looked pretty cool. Now that we have our electrical board in place, let's go over a couple things to keep in mind while mounting the components, and then we can hop right in and CAD our components. Alrighty, so this is what we have to work with right now. You might have noticed that we changed the position of the electrical board from the bottom to the top, and that is because we have a center drop on the drivetrain, meaning that the center wheel is a little below the rest of the wheels, and so here the sprocket would have hit the piece of Lexian while the drivetrain was moving, and so we had to move it to the top. That stuff like that is what you have to keep in mind when working on your drivetrain. And let's quickly go over things you should make sure when working on your drivetrain. So when working on your electrical board, you might want to consider these things. Now, there are more things you should look into when making your electrical component, but these are just a few I think people miss a lot. So make sure no moving parts will hit your electrical board. That's kind of a big thing. Like when you're making your electrical board, you want to make sure that no moving parts are gonna be hitting it. Like maybe if your robot has an elevator, you want to make sure the elevator, when it goes up and down, it does not hit any part of your electrical board or component. So you might want to keep that in mind when making that. As you may remember, we actually messed up when making our electrical board before because we put it at the bottom, but then we had to change it because of the sprocket, and so stuff like that you want to keep in mind. Make sure your PDB and breaker are near your battery. Your PDP and breaker are the two things that are connected directly to the battery, so you want to make sure they're pretty near. We won't be CADing a battery or having that on there, because then that just adds a whole weight issue of the robot and where you want your weight to be and stuff like that. So we won't be doing that, but you want to make sure those components are near each other. Another thing is that motors work with magnets, and the radio, which is your access point, your communication between the controller and the robot, the motors can kind of mess up the connection of that radio. So you might want to try, if possible, to keep that like as furthest away from them as possible. Now, that's not super important, but that's just something you should try to do. And another thing you should look into is that having your PDP in the middle of your robot in the middle of your electrical board, that would be really good, because your PDP kind of powers everything. So it's going to connect to the motor controllers, the RoboRio, the VRM, and so on. So you want to try to kind of put it in the middle so that everything can just connect to it pretty easily. Two other things I didn't include on there is that your main breaker which is the on and off switch for your robot. You want to make sure that's out, not really out, but at a spot where you can easily access it in case of emergencies and stuff like that. And your RSL also needs to be at a place where you can easily spot it, like feet away, like maybe 3 feet away. You should be able to see it and determine if it's safe to approach the robot.
Oh, nice. That's pretty solid. But Mueez, how are you going to CAD all those parts?
That's a good question. Well, I'm not going to. Fortunately, there are websites like Vex Robotics and AndyMark from where we can get the CAD files from and then just upload them to our document. Alrighty, now that we have gone over some of those points, let's start getting our components and uploading them onto our Onshape. We will be getting our CAD files from AndyMark and Vex Robotics, and of course the links to them will be in the description for you to check out later on. So let's get started. First, let's go to vexrobotics.com to get the CAD file for voltage regulator module. There may be instances when one website won't have a CAD file for a component, but if you look around to another to AndyMark, for example, then you might be able to find it, or just searching it on Google for a little bit can get you that component as well. So let's get the voltage regulator module. On Vex Robotics, when you search a voltage regulator module, you can see the price and you can buy the component, but if you scroll down, you see a lot of useful stuff. There is the user's manual, which we won't be covering right now, but a couple of important stuff is the drawings and of course the CAD files tab that we should keep in mind. So the drawings is important because here you can actually see the dimensions. So later on, when we CAD our holes on Onshape, we will be able to get the dimensions from here, so we won't have to measure them out on our own. So right now, let's go to CAD files. If you want, you can preview them to make sure they're the right component. This is the right component, so we are good right now. But right now, we're just gonna download it by clicking this download button. And after it's done downloading, we can head over to our CAD file here. And here we can go to the plus button, which also says insert element. Click import. We can click here. And just click OK. It may take some time to download, so while that's uploading, let's make a folder specific to components. So let's say electrical components. Ooh, that's not good. Let's rename that to electrical components. And There we go. We can move the voltage regulator module onto here, and there we go. We look on here, we have it right here, and we can start downloading and uploading the rest of them. So I'll go on ahead and download the rest of them, and I'll finish uploading them, and see you in a little bit. Hey guys, I am back, and as you can see in my electrical components folder, I have all of my electrical components downloaded. So what I'm gonna do now is I'm gonna show you how you can use your resources to mount your VRM, so you have an idea of what steps you can take for each component, and things you should keep in mind while working on that. So I actually won't be CADing all of the components and mounting them on, because each electrical board has a unique setup, and a robot has different mechanism at different spots. So it won't really be useful to see all that whole procedure. So I'm just gonna jump right in and just do the VRM, and just end it at that. So let's get to that. So we're actually going to go back to Vex Robotics. As you may remember, Vex Robotics has a drawing for some of the components where you can see the dimensions and stuff. So if we search up voltage regulator module and go to the drawings for it, and then you can see here the dimension of the hole we will need is 0.15, and how far you need to make the holes. So we can go back to our electrical board, which is let's edit in context so that we can also see where the other stuff, where our drivetrain is. So I'm actually quickly gonna create a new sketch, and make 4 holes. With the circle command, and I'm gonna dimension one of them to be 0.15, like this, and then I can just use the equal button here to make the rest of them the same size. There you go. Now what you have to first consider is how far you want the corner of your VRM to be. I would like it to be in the spot around here. So what I'll do is I'll bring it up to 1 inch. Actually, that was a bad call. I'll bring it up to 1.5 inches. And then I'll just move it left to around 2 inches. 1.75. There we go. And as you can see, the circle is now black, meaning that's fully constrained, and that is good because we can't just move it around. All we have to do now is just constrain the rest of the holes. So if we go back to Vex Robotics, the hole on the right is 1.883 away from the hole on the left. So we can dimension it like this to be 1.883, and dimension this to be 1.5 apart. 5. And now we have to do the other 2 holes. We do know that the holes are, it's a rectangle,
So this is also gonna be 1.75 away, and this hole is also gonna be 1.883 away. So now what we really have to determine is the distance between this hole and these holes. So that is 1.702. While you're doing this, make sure you're checking the dimension from the middle of one hole to the other instead of checking the dimension of the outside of the VRM, because that can get kind of confusing. So let's do this side, and you want to do the same thing over here. There may be better ways of doing it, but this is just a way I find easy for me. And that now that is done, we can extrude it, and we can press remove and do through all. And there we go, we have the holes for our VRM done. Now all we have to do is go back to the assembly and make sure that the VRM actually fits on there. It's a really good habit to check that your components fit on the holes before you move on, because if you don't do that, you might actually CAD your whole electrical board and later on find that some of the holes are misplaced, and so that can kind of be a bit frustrating. So to avoid that, I suggest checking that your holes are good. I'm gonna actually group it because I know that the voltage regulator module, as you can see here, it has so many small parts, so we don't do that. Like for example, the red block here would end up flying away, and we don't want any components flying off of our electrical board. So we can fasten this hole. You can do any hole. Actually, we can't do any hole. Yeah, so the 5-volt one is, yes, there we go. So this is the position that my Roboria would go on here. So if we do this, and oopsies, there we go, we should be able to check that off. And once we look from the top view and we look straight down, our holes meet. And so you might see this funny thing, and that's because the electrical board is transparent, and so this hole is just the bottom hole, so that's nothing to worry about. And so all you have to do now is just kind of do all of the rest of your components. I would suggest you draw it out first, so you have an idea of where you want to have your components, so when you start mounting it, you don't have to kind of take components off because they're too big or too small, or maybe you don't have space for them.
Now that's how you can CAD your very own electrical board at home.
Alrighty then, thank you guys for watching today's video. Make sure to like, subscribe, tap the bell icon, and stay tuned in for more Time Robotics content. I hope you guys enjoyed the vid and have a good rest of the day.